For this section under AMAP trigo, it is a non-calculation section. So in this section, you will not be asked to calculate or sketch. So you'll be proving formula. So the idea of proving formula is to make use of formula, and then you start from the more complex side, and then you reach the other side. So that is like identity. So there are some very, very complex one, and a lot of students have a lot of issues with this topic because they will always end up with, I don't know which formula to use. And of course, you actually need to play around with the formulas. Plus, you also need to know that there are certain techniques that are involved. The techniques that are involved are very simple. It can be what you learn in Sec 2, like take out common factor. It can also be your algebraic expression like a plus b squared. So it can be make same denominator. So all these are the common technique that we'll be using. So I will be using some examples, but then my idea of the examples is to show you what are the available technique. So as a bigger picture, all these technique you should also be thinking of the technique together with the formula. The few formulas are here. So the formulas are here. So this is like formula 1, formula 2, formula 3, 4, 5. So these 5 formulas are not provided in the exam list. So these 5 formulas are not provided in the exam list. Okay, so some of the confusion will be like, for example, among these 5 formulas, so there is a cotangent. This is also a cotangent. So apparently there are 2 formulas for cotangent. So in face of cotangent, sometimes some students will be like, so which one do I use? So if you're not so sure, then you got to try both. Okay, so that is one of the confusing thing. And there are some students who always end up choosing the wrong formula. And then you keep getting stuck. Why can't I prove? Why can't I prove? So if you find that it doesn't work, you got to switch it. You got to switch formulas already. Okay, so that is the approach to proving identities. Okay. So this, the next one, right? This block is the one that is given in the exam list. And these formulas are manipulatable. That means you can manipulate. So you can reshuffle. You can reshuffle. I think in the part in trigo teaching worksheet number 3, where you learn trigo equation, I did mention you can actually manipulate. So you can manipulate like this. So the formula can be switched around. So like for example here, it can also be switched around. Okay, so here it can also be switched around. Okay, back to the basic 5 formula. So for the basic 5 formula, right, sometimes I can do something like this. I can have a tangent square. So from tangent x equal to sine x over cos x is actually sine square x over cosine square x. So same thing here. Here I can make it into a cotangent square. I should have typed it in x. So because of this, right, then in terms of tangent square, some students will be like, for tangent square, right, most people will think about this. They wouldn't think of this. So these are the 2 formulas. These are the 2 formulas. So sometimes, right, for an expression, there can be more than 1 formula. So that's the confusing part. So same thing here. If you look at cosecant square, I mean, cosecant is 1 over sine x. So cosecant square will be 1 over sine square x. So if you're not aware of this, right, it actually makes your proving very difficult. So like for example, this one secant x is 1 over cosine x. So that becomes a secant square equal to 1 over cosine square. So same thing here, this part, okay, got running out of space. Cotangent x is 1 over tangent. So cotangent square can be 1 over tangent square. So all these could be used. So if you look at cotangent square, there are two formulas. It can be this or it can be this. So it gets quite confusing. So what you need to know is there can be more than one formula for an expression. If it doesn't work for this formula, you just have to change. So after a while, you will have the instinct, what should the formula be? So generally, proving shouldn't be very long. If you already like work out like 6, 7 steps and you're not so near to the proving, that means you're on the wrong track. Your technique is wrong or your choice of formula is wrong. Okay, so and again, right, if you're going to do proving, right, you got to start from the more complex side. Okay, so like for example, if you look at example 1a, we got the left side and we got the right side. So this is the left and this is the right. So apparently the right side looks more complex. That's why I'm starting from the right hand side. So when I start from the right hand side, my concept should be, or my thinking should be, I must use a formula. I must use a suitable formula. So cotangent x, there are two formulas. Another formula is this. So I will actually use the cosine over sine because that enables me to cancel. And when I cancel, I will get the cosine x that I'm supposed to prove. So it doesn't matter. You can prove from right to left or left to right. Okay, so this is one of the simpler proof. I don't think you'll be asked during exam. It's just an idea. So you take the more complex side. When you start from the more complex side, decide the formula. So in the next question is, of course, the left side is look more complex because it's a huge fraction. So one of the technique is to see a fraction as a divide. So it's something like you see as a numerator divide by denominator. So that's what I did. So it would be like a numerator divide by a denominator. So that's my approach for this question. And then, right, this one has a formula. So that's why if you look, I change it to the formula. So I change it to the formula. And after I change it to the formula, I realize that I'm going to make it into a fraction divide by fraction. So I'll make it into a single fraction. So I'm trying to make it into a single fraction. Okay, why do I want to achieve the idea of a single fraction? Because in primary school, you learn that when you divide a fraction, you flip over. So there is a reciprocal here. So I did a reciprocal. And because I did the reciprocal, I have a cancellation that I can do. So when I see a huge fraction, you can look at it as a numerator divided by denominator. And then obviously out of the whole fraction in this question, cosecant is the only one that has formula. So you put in the cosecant formula, and then you should come to you like, okay, since I have a fraction, I try to make same denominator. So from here to here, I actually make same denominator. So that's one of the technique. So in this question, I make use of the make same denominator technique so I can apply my reciprocal. And then I end up doing some cancellation. Okay. And in the next one, right, you realize that you don't have a complicated side. So if you observe the left side and the right side, they look equally complicated or equally easy. So in such a case, it doesn't matter which one you start with. But then if you look at the left and right, you got to think of the formula. So the left side involves cosine squared, the right side involves sine squared. So the formula that I think of should be sine squared plus cosine squared equal to 1. And remember, this formula can be twisted. So I can actually twist the formula to get these subsequent two formulas. So for example, now I choose to start from the left-hand side. I should think about getting rid of this so that I can get my right-hand side. So how do I get rid? I'm going to use this formula. So I replace with this formula. And then I eventually get to the other side. I expand out the bracket, I get to the other side. So if you are starting from the right-hand side, then you should be thinking about how to get rid of sine square so that you can get a cosine square. So you should be using this formula. So you realize it doesn't matter which side you start with, but you must think of the correct formula. So if you didn't relate this question, when you see the left and right and you didn't think of using sine squared plus cos squared equal to 1, then you're going to be stuck. So it's also the instinct. Anyway, sine squared plus cos squared is one of the more frequently used proving. Okay, in part D, right, you actually got a number subtracting a fraction. So if a fraction is there, you can think of making same denominator. Okay, so later on, I'll show you the part about making same denominator. Okay, but obviously this is the more complex one. You should start from the left, then you go to the right. So you're hoping to achieve the cosine x. That means, right, if your technique is correct, your formula is correct, the big chunk, right, can be reduced to a cosine x. So in this part, right, I'm not making same denominator first. I'm actually using this formula first. I'm using the sine square formula, this part. I'm using the sine square formula, and then I get to a 1 minus cosine square. And this is a technique. I actually apply a square minus b square factorization. So it's something like 1 square minus cosine x square. So if I factorize according to this sec2 formula, this is what I got. So that's exactly how I gotten this. So this is also a technique. A square minus b square factorization is also a technique. So after I do this factorization, I can cancel. That's why I'm left with this. And when I expand out, I'm left with a cosine. Okay, so far I have been ignoring the 1 here. So I was very, very focused on the fraction. So I replace sine square with the idea that I can actually factorize. So a square minus b square factorization is one of the possible techniques sometimes. Okay, so another approach to this proving, okay, will be I'm going to write the a square minus b square here. So you can remember that there is a technique. So please jot down the technique. Okay, another approach to this question is to make same denominator. So if you take a look, I'm still starting off from the same side. So I'm going to make same denominator. So the whole number 1 can be written like this. And because the denominator are the same, you got a huge fraction. And in the huge fraction, you also see this formula. So you get rid of that formula. So I replace the formula, I expand. And at this stage, my 1 can cancel. My numerator became cosine square x minus plus cosine x. I'm going to take out common factor. The numerator has a common factor 1 cosine x. So as I take out, I'm actually able to cancel away. And I'm left with a cosine x. So for part D, this will be the 2 approach. Both will get you full marks. Okay, both got some amount of factorization. In the first method of factorization is a squared minus b squared. In the second method is just taking out common factor. Okay, so these are the few factorization technique. Okay, in part E, okay, which are more complex? Okay, the left side is more complex. And the first instinct, right, I hope when you see this, you will have thought of your set 2 expansion. Same for this. So you should have thought of your sec 2 expansion. So if you never thought of this sec 2 expansion, that means, right, you wouldn't be able to continue. So I apply my sec 2 expansion. This one, another sec 2 expansion. So if you apply your sec 2 expansion correctly, you actually manage to cancel the 2 cosine x, the 2 cotangent x, and the 2 cotangent x. And then you also end up with a 1 plus 1. And you also end up as a cotangent square plus cotangent square. So that's how I get a 2. And it's quite obvious from here there's a common factor. 2 is a common factor. And after you manage to take out the common factor, if you are not so familiar with the formula, you will not realize that this is a cosecant square. You will not realize that there's a cosecant square. So if you recall back your formula, that will be this set of formulas. So I will suggest you memorize a formula. If you can memorize a formula, you can relate to which one to use faster, rather than you are so handicapped. So if let's say you couldn't, then you just have to keep staring at the formula list. Okay, but do recall, only the red color one is like provided. Formula 1, 2, 3, 4, 5 is not provided. So you need the awareness of the formula, which some of you find it very difficult. And again, if you know that there is a formula, you also need to know that cosecant square actually came from the idea of cosecant x equal to 1 over sine. And therefore, if this is a cosecant square x, it's actually 1 over sine square x. So this will be the formulas that you need. Some of you may not have this in your head, so you will find proving very difficult. So far we have the factorization technique, we got the expansion formula, we got the make same denominator technique. Okay, and of course we got to teach around our formula. And we also got the reciprocal thing. Okay, so all these, right, later on you'll revisit. So these are the core technique.